Hi everybody, I just wanted to do a really quick example problem showing you how to solve a free fall problem using the big three, just in case you want a little bit more of a refresher on that. So let's take a look at an example of a kangaroo or an animal that can actually jump up from the ground and go pretty high. There's an antelope that can actually jump up and go pretty high. And they're known to leave the ground, like the speed, after it does the initial part of the jump, the speed with which it leaves the ground, let's assume that's at height 0, just to simplify, is about 7 meters per second. Okay, so that animal is going to go up, stop briefly at the top, and come back down. And it's going to impact the ground with some velocity too. And if those are at the same height, because gravity works the same way on the way up as it does on the way down, we can conclude that that impact velocity on the ground is negative 7 meters per second. If the heights weren't the same, we couldn't conclude that. Now, one other thing I just very quickly want to note is the impact speed is not 0. Yes, the animal would be at rest once it hits the ground and comes to rest, but when we're talking about sort of with what velocity does it hit the ground or what velocity does it strike the point, we're always talking about the impact velocity with which it does the impact, not after the impact. Okay, so here we go. We have this situation, and you want to know two things. You want to know how long to get to the top, and you want to know how high it gets. Those are the two questions. So let's remind ourselves of a few things. So first thing you have to do is define a coordinate system, and I always recommend for gravity problems calling up positive and calling the ground height equals 0. Okay, so now what we see is that if we do our knowns and our unknowns, I don't know why I wrote K and unknown all the way out. That's really random, but here we K, N, O, W, and knowns and unknowns. We know that our V initial is 7 meters per second. Now, initial we're calling here. If we're interested in how long it takes to get to the top and how high it gets, we're actually calling final the top. So you always have to think in some of these problems. There's multiple places you could call final and initial for that matter. And so what we want to do is start at the bottom and end at the top. And what you might remember is that the velocity at the top is briefly 0. Even though you don't stop accelerating, even though gravity is still acting on you, for a very brief moment at the top, you pause as you change direction to come back down. Okay, so we do know our V final is 0. We know our acceleration is negative 9.8, negative g, because the acceleration, whether you're moving up or down, gravity is always pulling down on you, so your acceleration is always downwards. On the way up, your velocity is positive. You have a downwards acceleration, you slow down. On the way down, they're both pointing down. That's why you speed up. Okay, we don't know the time. We don't know the x final. That's actually what we want to figure out in B, our final position, but we do know that we start on the ground. So let's think about which one is going to let us get the time to get to the top. Well, we have a couple. The first two equations of the big two have the big three have time in them, but the second one, the one also has x final, which we don't yet know. And so the equation that's going to be the most efficient way for us to get this is the first one. V final is V initial plus AT. And so V final is 0, V initial is 7 meters per second, plus negative 9.8 meters per second squared. Don't forget your signs and t. And you'll see how that sign is really important because it's going to give you a positive time. And so the time winds up being negative 7 meters per second over negative 9.8 meters per second squared. And the negatives cancel. And if you work out your units, you'll also see that you get seconds. And I get about 0.71 seconds to get to the top, which means, incidentally, the total time is going to be 1.42 seconds for the whole trip because it's starting and ending at the same height. Again, that wouldn't be true if the heights initial and final weren't the same, but it's just worth noting. Okay, let's do B. Now we want to get how high it goes, and that's where we're going to be solving for x final. So x final is x initial plus v initial, which we know is positive 7 meters per second, times the time to get to the final position, which is 0.71 seconds, plus 1/2 times the acceleration times the time squared. Okay, and I just need to calculate that out really quickly. 7 times 0.71 plus, minus 0.5 times 9.8 times 0.71 squared. And I get about 2.5 meters, which seems really high. That's like a really, 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 really high number, and that's okay because this is a pretty fast launch speed. 7 meters per second is really fast. So x final is about 2.5 meters. And that's why this is a cool problem, because this animal can jump really ridiculously high. All right, so that's it. I hope that helps. Just take a peek at this if you want some guidance in working on the assignment problems for tonight. Okay, bye.